There you go. Okay, welcome everyone. I think we're just going to start away, and we're just going to give an introduction to Git. I know Alexander gave a presentation on this and he gave a video and a whole bunch of links and books to read, so I'm sure everyone's read all of them and gone through it all in detail. But this is just another step through for us. Myself and Kieran and John here, we've been kind of just looking over Git for the last week. We've moved a lot of our source up to Stash, and the plan is today at 3 o'clock, I think, to get all our check-ins done and everything like that, and then move over to Git. So what I'm going to try to do in this demo here is basically maybe take down a project from Stash to show you what you kind of need to do there, showing menu options and stuff like that, and then just maybe going through some of the concepts of Git, kind of the main ones that you kind of need to know, and just maybe give some information. Okay, so basically to start off, I just have a few slides here as well, just as I go along, just to keep me on the right track. The first thing is, I suppose, to know about Git anyway, is Git is distributed. So this means that you have a local repository which lives on a special folder on your computer called .git. So this is obviously different from the way we're used to working with TFS. And another thing to note too is each collaborator has an exact clone of the repository on their local workstation. The advantage of this is, as you'll see later on, it is very easy to make your own branches. Okay, and to make your own branches and stuff like that. So you can do much more stuff on your own PC before pushing it back up to the central repository. I thought too it might be useful just to give a few of the main bits of Git terminology. I'm sure most people who've worked to kind of source save and TFS will know all these kind of terms anyway, but no harm just to go through them. You can see there that master, so that's the repository's main branch. At the moment we've set up on our talent source, so what we have at the moment, we've got a development branch in our repository and we have a master branch. This strategy, I presume, we can change in your repository. You can have many branches as you want, but that's what we've gone with at the moment. The idea of cloning, you'll see when I'm taking down a project later on that you clone a repository. It's just the way of it's just the word of making a copy of a repository. So it's when you're moving from your remote location to your local environment. Committing, we all know what committing is, submitting files to a repository. Fetch or pull, so that's when you're getting stuff down from the repository. Push, so you're going to push stuff from your local repository when you have the work done. You're going to push it back up to the central repository. Remote, we all know what remote locations is. SHA, SHA, however you pronounce it. This is, every committer node is identified. It has its own unique SHA key. Head is a reference to a node at which your working space of the repository currently points, and a branch, just like we're used to working with, a branch is just, actually in Git it's slightly different. A branch in TFS would have been a different set of files that we would have branched out of our main code. This is not the case in Git. A branch is nothing more than a particular label of a given node, so it's not a physical copy of the files. So it's just a different way that Git works. Okie dokie. What's my next one? File states in Git. Probably don't need to quite. I'll go through this just quickly and then I'll take down a project and we can show then exactly what we mean by some of these ideas. A file in a working tree, a repository can have different states. These states are the following: untracked. Untracked is basically a file which is just a file. You haven't hooked it up to Git, so it's not being tracked by the Git repository. Files, untracked files, you can also, Alexander, if you watch his video, he used the git ignore command So basically you can set this up. I'll quickly probably show you that as well, just so that you can exclude files that you don't want to be tracked by Git. So that's pretty much what untracked is. Track files, committed and not staged. This is stuff that you've committed to your local repository. Staged, we'll go through the concept of staged later on. Staged is a file that you have done work in, but you have not yet committed to your central repository, so it's kind of a middle ground. I'll give more examples on this and show you how that can be actually useful. And the last kind of file state you have are dirty modified states. So these are files that you've worked on, but you just haven't saved them and you haven't put them into Git in your local repository yet. Okie dokie. I think the next thing what I want to do, let's not show you that slide. Let's go up and have a look at Stash. Okay, here's Stash. We can have a look at all our projects. We can see our projects here, Talent and Solaris. You can see Agda and Visma Common, they've all got their stuff up here as well, but we'll drill into our own one. And you can see here then we've got the idea of repositories. So at the moment, Kieran uploaded all this stuff here, so we've got all our modules, and these are all called repositories up in Stash. And the project I think I'll take down is education, since I can mess that up and I'm the only one that's going to be affected by it at the moment. You can have a look when we drill into education that at the moment we have, as I mentioned earlier, 2 branches, development and master. You've got the idea of tags as well. The idea of tags, which I'll go into later on, is like tagging a certain commit that you can use for releases and stuff, but I'll go into a little bit of that in a small bit more detail later on. But we have no tags set up or anything at the moment, we just have our 2 branches. What I will do, I think, is I will bring down the education project to my local machine. You can see up here that we've got the clone button. So what I'm interested here is the HTTP. This is my link to this Stash repository. So I'll just copy that. Go down, I think I'll open up an instance of Visual Studio. You can see I have a Git menu up here, and I'm going to clone the repository. So I will point my link in repository to clone. I will point it to the education, the destination. So I'll just browse my local machine. Documents, project, all standard. Specify the name. I'll just make that uppercase for readability. And the last step is I will select the branch which I want to get down from the central repository. I am going to take down the development branch. I'll just leave the others at default, and I will clone the project. So at the moment, it's going up to the central repository and dragging all this down to my local machine, a full copy of everything that is up on the central repository. So that is the whole idea of Git, is that you have, the repository you have in your machine will be a full copy of everything that is up in the central one. Well, the branch that you take down, obviously. So that's just chugging away, taking down all the information. And that's done. Okay, let's just have a quick look and see exactly what that has done. Into education. Okay, so we brought education down, so it's brought down all the usuals. But what it has done is we now have a .git folder. So this is going to manage all our interactions with Git, all the different versions and branching and everything like that. You'll know it's also created the git ignore file. So that's what I said earlier on, that you can specify files that you do not want to be managed by Git in the git ignore. Again, Alexander went through this in a bit of detail in his video, so you can have a look at that if you want more information. Okay, what I'll do is I will now open up this project and just show you the various menus and such like in Visual Studio that you will be working with to interact with Git. I need to set up we were having a problem with opening up the solutions and getting the IIS side of things working, so I'm just going to actually create manually the application. Just point it to my education folder. Okay. Project. Alrighty then. Okay. So now we've taken down my education project, and I've taken down from the central repository. Now I've opened up my local repository. The first thing to do, we are used to working with TFS, but we need to change over to let our source code be managed by Git. So go into the options, my plugin selection. For some reason here by default it goes with the Microsoft Git provider. That is not the one we're using. We are using the Git source control provider. So I select that. Okie dokie. And you will see that in my side panel here I have now a pending changes. You can see my pending changes up here. We'll take straight example of pending changes and merging and stuff like that. But my pending changes shall go into this area here. I can commit them, amend the last commit, I can switch branches up here, etc. You also have the option of right clicking on the file. Going down, you have another Git menu in here. So you can do stuff like you can view the history of files, blah blah blah, you can commit them, you can stash another rebase, do all your bits and bobs from this menu here as well. And finally, the other menu which we tend to work with is up here. It's Git. We saw earlier on that we use this menu to clone the repository, bringing our project down from the central repository. This one also opens up Git extensions. Again, these add-ons are so we can open up the Git extensions. You can see here. So Git extensions then shows me. We can see all the history of what's been done since when we put the education project up to stash. We also ran a tool in it to bring up all the history from TFS, so that's all reflected here in this panel. Again, I'll show you examples of using this, but if we actually just show maybe a specific file. So let's just open up one of these guys, the maintain course file. We can browse with Git. Yeah, I'll do that later on when I do more specific examples of changing a file. But just the other things to notice here is that you can see the commits here, you can see the file tree, and you can also see differences. Again, when you make change to the files, you'll want to see the differences or who's made the changes. This can all be done here. Dum, dum, dum. Okay. Let's open up my PowerPoint. Let's have a look what we were going to do next. Yes. Okay, so we got the idea of staging. Again, if you look at Alexander's video, what I'm trying to do is actually just kind of maybe delve into areas which Alexander didn't go into in such huge detail. So he showed merging stuff. I'll give you quick examples of that kind of stuff, but it was just a few concepts which I was trying to get my head around during the week. So I've just kind of stuff that we aren't quite used to. We're working in TFS. I said I'd try and highlight these and maybe just give examples of these and show the differences. Staging is one of those things. The best example I could find online is basically staging. It's basically a loading dock where you determine what changes get shipped away. You can see in the local operations, again we're working locally here. You have a working directory, a staging area, and a Git repository or Git directory repository. Again, local. When we're checking files into TFS, you committed them and you committed them into TFS. Simple as that. In Git, you have the option to stage the file, which I'll actually show you now. Just as we go along. So let's go here, let's get an education file. I guess it doesn't really matter. Okay, so what I'm going to do is I'm going to just add some text here. So I'm going to say first change. Save that. That should pop into my pending changes right here, because Git is keeping track of my files. It knows that I've done something with them and I've changed that file. Okay, now what you can do is you can click this button and this in effect stages the file. You're saying you want to commit this file. I commit this file. I can add a comment here. The file is committed to my local repository. All very standard and normal. Nothing to see here. If I go to this menu, which goes into Git extensions, I have a few more options. If you look down here, you can see that I have a stage. So what I can do is I can stage this file. The file is now staged. This is the exact same as clicking on the buttons here, but here you don't have the option to do stuff. So we were discussing yesterday the advantage of staging. So I'll just go down to my next slide. The advantage that we can see of staging anyway, again, most times you'll be using this, you'll just commit. You'll just click on that bus, you'll commit your changes. The advantage of staging, as far as we can tell in Git, is that it allows the developer to commit parts of a file. You can also, at this point of staging, you can stash your changes. Stashing is a concept which I'll go into a little bit of detail on that because it's quite interesting. But again, I'll just go back to my screen. My Git extensions. So in theory, we have a file here, it's ready to be staged. You've made multiple changes on the file. What you can actually do is you can drill into the file and you can commit parts of the file. This could be useful, I suppose, in certain scenarios where if you've made a lot of changes, but you know you don't want all those changes to go in, or there's only a certain part of the page that you want to actually get committed. You actually have control over that, so that it just offers another level of management of what you actually commit into your repository. So that's pretty much the idea of staging. But I'm not going to just, again, those options here are based on right click, so you can just go to the line. You can see the green represents the change. If you had multiple changes, you could commit them one by one. But I'm not going to do that now. I'm just going to actually commit my change, and I'm happy with that. So every time you commit, I have to give a comment. So I'm just going to call that the first commit, and then I'm going to commit it. You'll also see you've got other options here. You can actually commit, but you can also commit and push. Commit and push means that you're committing to your local repository and then you're pushing that change up to the central repository. So you also have that option. But at the moment, I'm just going to commit to my local repository. There you go. Now let's have a look in Git extensions. You can see here development, first commit. There it is represented in the Git extensions window. That commit, you can look at the file tree, so you have access then, you can see the files and stuff that have changed. You can also run a diff and you can see basically what changes. So for all information on that commit, you can open up your Git extensions and drill down and get everything you need to know. All good. The next concept. Okay, the next thing I was going to talk about my PowerPoint is stash, but I'm actually just going to go back into Visual Studio. And what I might do, I know Alexander did this as well, but I might just show you one of the powers of Git and how easy it is to make a separate branch We all know that when we're working on something, if we want to try out a bit of code, or you know, you want to make a few changes, you don't want to put into your main branch. So what you can do here is you can make just a separate branch, and you can call it a test branch or development branch or a feature branch or whatever you want to call it. You can go away, do your stuff, and then you can switch back out to your other branch without ever having to commit those changes. So the easiest way to create a new branch to test this, so I got my first change there on my main branch, my development branch. I'm going to switch branch. You can do it here, or you can do it from up in this menu, but I'll just do it here. It says switch branch. I only have the one branch at the moment, so I'm just going to create a separate branch, and I'm going to call that branch 1. Name branch 1's not out. Okay, obviously spacing. Branch 1. Okay, now, as quickly as that, we've created a new branch. You can see up here, pending changes, branch 1. Also, the commit, branch 1. These are the two identifiers to show that I am now working on branch 1. So, I guess I can come down here and I can make a change, and I can call that branch 1 change. And let's save that. You will see branch 1, I've got a new file that needs to be modified. Okay, so I'm happy with that, so I'm going to call that branch 1 change, and I'm going to commit my change into branch 1. Okay, so I'm working away in branch 1, Okay, so I've committed my change. I now need to get back to my main branch because I need to fix a bug or something like that. So again, to switch branch, it's as simple as going back here. Again, it'll ask me to reload the thing because I've changed branch. Dum-de-dum. So now I'm back to my main branch, and just the first change is the only bit of code. So it's reverted the file back to as it was in the development branch. So that's as simple as it is as creating a new branch. You can create as many branches as you want. You can, using Git extensions, using the merges, you can merge multiple branches into a single branch. I presume this is as easy or as hard as you want to make it, depending on each situation. What I'm going to do now is I'm just going to show merging. So on my development branch, I've decided I want to merge my branch 1 into my development branch. Pretty simple example. We're just going to press merge. So my main branch, development, I'm going to select the branch 1 that I had. Always create a new merge commit is the option that I'm going to keep selected here, and I'm going to merge my change into the main branch. You will see it asks me to reload the file. There you go. So on my development branch, it's now taking the changes from my branch 1, and that is now part of the development branch. You can see using the Git extensions what has happened. So if I just go to browse, go into Git extensions, there you go. You go up in your tree, it knows here that I've got branch 1. I've made a change to branch 1, and this little icon here shows that branch 1 has been merged into development branch and has taken the changes from branch 1. Okay, so that's just a simple example of how easy it is to branch and merge. What I'll do is I'll go back to my PowerPoint. For the next concept I'd like just to show. Is the idea of git stash. Git stash, I took a few definitions there that I thought I explained it from the internet. Temporarily setting aside work in progress. The example that we have here is that you are working on a change or a feature on a branch. Say that we're putting some new code in, you're halfway through it, then there's some bug escalation, something happens, you need to switch back to your development branch. You are not happy with your changes because you're not quite finished with them, so you do not want to commit them into your branch 1. And if you're not happy to save them off and you switch back to development branch, that means you lose the changes you were working on. Git offers you the ability to stash those changes. It's like just putting, I don't know, what does it say here? In Git, stash operation takes your modified track files and status changes and saves it on the stack of unfinished changes that you can reapply at any time. That's better than I could have put it. I'll show you the example though, that how it actually works is probably the easiest thing to do. We'll go back in. Okay, so what we're going to do is, again, we're going to switch branches. So I'm just going to go to branch 1. And we can see again, branch 1, branch 1. I'm working on branch 1. Okay, so let's say I'm going to make a change. And I'm just going to call it whatever it can be. I'm just going to call it an uncommitted branch 1 change. So let's save that. That popped into my staging area here. Okay, so then basically what happens is I've been working away like that for a few hours. I've made change to a bunch of files and such like, but then escalation comes in. You got to switch back over to your other branch. You got to fix this. You got to push that up to the central repository. I'm not happy with this stuff. I don't want to check it into my. I don't want to commit in there, but I also don't want to lose the changes either. So basically, I have the option of stashing this change. So if I go to Git here, I can stash it from here. Again, I can go here, and I can also stash it from my Git menu here. Stash it. So let's stash that change. So it shows the files that I'm currently working on. There are no stashes at the moment. Blah blah blah. I'm going to save that change. Okay, you can see now I've got a stash. Now I presume I can rename my stashes and stuff like that, but I haven't messed around with that too much. But just to show the concept, I now have a stash. Okay, so let's close that down. It asks me to reload. My change is gone. It's now stashed. It's no longer part of my branch 1. I'm going to switch back to my development branch. So I'm back now in my development branch. I fix up my escalation, I do whatever changes I need to do in my development branch. I'm happy in it. A few days later, a few hours later, whatever, I want to go back to my branch 1. So let's switch back to branch 1 again. Okay, so now I've got my file, and I basically want to bring back in my changes that, I've got time again now to work on them, so I want to bring it back in. So we'll use here, we'll go to stash, dum-de-dum. So I've only got the one stash at the moment, so that's the one that I've selected for that file. You can see in the window, the uncommitted, so that's the change that I'm bringing back in from stash. And then it's as simple as, you have options. Again, I haven't messed around with actually bringing in stashing specific parts of the file or anything like that, but again, you get the idea. So when I apply selected, I'm now dragging the stuff down from stash, putting it back onto my file again. So when I click this OK and close down this window, yeah, Visual Studio asked me to reload it. Yes to all. My change, which I had stashed away, is now put back onto the file, and it's ready then to be committed back into my branch 1 of my local repository. So then I'll just go in and commit the change. So stash change, and we'll commit that in there. Okay, and if we go on Git, just to show the browse, so branch 1 has a new change in there, stash change. So that's pretty much stashing, the concept of stashing. Let's go back to my PowerPoint.
If somebody has used TFS, this was called shelving.
Sorry, can't hear you there, Alfred.
If in TFS, this was called shelving of a change and getting it back.
Yeah. So you had the same kind of concept. Yeah, I never used it too much in TFS, but it's just handy to know these things. Okay. Now, so that's stashing. Okay, Git tags is just another concept. So Git has the ability to tag specific points in history as being important. So generally people use this functionality to mark release points. I suppose the best way to describe tagging is tags act as read-only branches. You can use a branch as a tag, but you may inadvertently update it with new commits. Tags are guaranteed to the point of the same commit as long as they exist. So it's the idea that you're working on your branch, you can come along and tag it, and then Git will mark that. So I think generally from reading up on it is usually people mark for release points or whatever, I suppose, specific areas of code that they want to save. So you can mark this then with a tag, and then you can push that tag, or you can always refer back to that set of code using that tag. Let's just go back to Visual Studio, and we'll go into our Git extensions. And tagging is as simple as create a new tag. So then you can call that version, I don't know, 1.0. So let's just create our tag. There you go. This commit, or this part of the code is marked as version 1.0. You have options then to push tags, and it's something which we can look into more, or we can use as much or little as we like and investigate more. But the concept of tagging it seems to be quite useful. Let's have a look at the next thing. Rebasing. I'm not sure how much I want to get into rebasing and stuff like that, but I just thought I'd mention it since it seems to be another one of the core concepts of Git, and it's mentioned quite a lot, and it's probably just useful for people to be aware of it anyway. There seems to be a lot of confusion when you look up rebasing. It's quite hard when people seem to have a lot of problems with the idea of it. But the best definitions that I could get were rebasing is the merging of two lines of development together while that's not rebasing, but merging brings two lines of development together while preserving the ancestry of each commit history. So it's like in TFS, we're working on stuff, we check it in, you can see who's worked on what in the files, and you've got a history of exactly what has happened to this file, and you also know exactly who's done what to the file. In Git, you have the option of rebasing. So again, the best definition that I could get is rebasing unifies the lines of development by rewriting changes from the source branch so they appear as children of the destination branch, effectively pretending that those commits were written on top of the destination branch all along. That makes sense? You can see the picture here. So basically what rebasing is, it's rewriting the history of the branch. Let's go across. Actually, I'll send this on. There's actually quite a good. You can hardly read there; it's a bit low, but there is a decent example here that I took online of the concept of rebasing. You can look at that at your own time. Just a few other lines in rebasing. You need to merge local changes that don't need an exact history. Again, I think the main rule that about rebasing from my research is that if you're doing work locally and you're the only one working on branches, so you might have 3 or 4 branches, you're merging them all into one branch, it might be a very complex piece of work, you don't want all that history and all that clutter, then you can rebase it and it'll basically reset the pointer, clear the history, and give you a nice linear branch again. But again, I think the rule from what we're reading online is basically if anyone else has done any work on that branch apart from yourself, then do not use rebasing, because it is very dangerous and you can run into a lot of trouble because accountability can be lost and also changes can be lost. So more concepts to be aware of, maybe use locally, but not something that we're ever going to use on the master or development branches.
If you create a branch on your own local, so Mike created branch 1 there, that isn't available to the public. So Mike is keeping that local so he can rebase the changes on top of the development branch. But if we create an 1160 branch, we publish that to stash, so everybody has access to the 1160 branch. You should never rebase the 1160 changes on top of development, because that will rewrite the history for everybody else, and everyone else will not appreciate it.
Yeah. So rebasing is not something I think we want to get too much into.
Yeah.
Yeah. Until we really understand it anyway.
Yeah.
Okay, go back to Visual Studio. What else can I show? I don't know. Am I missing anything? I think I've gone through most of the concepts. Any changes you do locally, you just push them up to the central repository using your Git extensions. That's pretty standard. You have an option. Let's have a look in here. You can use Git Bash, I suppose. Anyone who's read the PDF that Alexandra sent around will see that Git is extremely powerful. Git extensions and the plugins to Visual Studio and stuff like that are only exposing a part of what Git can do. It has an absolutely huge amount of commands so that you can use to alter or do whatever you want to with your repositories. Git Bash is just let you access that. So I think what you can do, git log or git log, and that should show me the changes. Yeah, so that's just a basic command here that shows me the changes that I've been doing there when I'm showing you this demo. Again, all that information is available on Alexandra's page and on the PDFs, or there's plenty of documentation online on Git. Yeah, can't really think of anything else to go into really. I suppose just to say that the plan today is, I think that all check-ins will be done. I think is it 3:30 today, and we plan to get all the latest of our source up into Stash, so that on Monday people can come in and start bringing the projects down from Git and start, using exactly what I've kind of showed you here to commit and to change their work. We will be available to help people with that changeover, so if there's any problems or anything like that. I've brought projects down for the last week or so, and I've been working back and forth with them, so my knowledge is increasing all the time. And Kieran and John especially are more than willing to help everybody. I think that's pretty much it. If anyone's any questions or queries or anything, feel free to ask.
I have a question. Why are we not using Microsoft Git provider?
We're not using Microsoft Git because basically it was too new, and I talked to Alexander on this because it was the question which I asked to him. He investigated, when he was doing his investigation just a few months ago, version 1 of the Microsoft Git provider had not been available, and the functionality he didn't feel you just at the time you didn't have the options, and it was too new. But he also said that it doesn't and shouldn't matter what people use as their source control provider. If you want to investigate, or if anyone wants to investigate using the Microsoft Git provider, then do. It shouldn't actually matter, because you're only going to be working on your local repositories. They're the same Git commands, it's just another way of doing it. It probably might make some of the right clicking and stuff maybe a bit more available. I'm going to actually play around and try to make some of the Git extensions, maybe just make them a click or two easier to get to. I'm sure you can make better shortcuts and stuff like that. But that's the reason why we didn't go to it anyway. It was too new at the time. I looked at it there the other day. It's at version 1.0 now, so maybe it's perfectly fine to use.
Okay.
Yeah. Anyone else? Anyone else have any questions or queries? Okay. Again, get all your code checked in by the end of today. Very important, or else you could lose stuff. And we're available then to.
I have one question for the code check-in from this afternoon. TFS can handle binary files, no problem. Does the Git ignore do that?
Sorry, Alfred. Just your.
Does the git ignore automatically specify all the binary files?
So is it ignoring the binary files at the moment? Is it? Is that what you're asking? Yeah, I've already created I've added a git ignore. I've taken a standard template off the internet for a git ignore template for Visual Studio, and it'll automatically ignore them. So when I've created the projects, I've added the git ignore file already.
Yeah, okay, of course. Git is only source, not binaries. It can't handle them.
It can't handle binaries.
Now, TFS knows and stores the whole binary, but Git tries to do it as a source file.
So hang on, sorry, I'm a bit confused. Are you asking is Git going to ignore the binary files?
Yes, and you said you can do that if you use the template. So if you send a template, or at least have it in the Git available as a standard, then it should be okay.
Yeah, I have that set up already. So when you won't need to do it yourself, like as in the git ignore file is in all the projects and the repositories. So it won't look to read the binary files or to try and sort or add them to source.
That's what I was asking, if you had it done.
Yeah, I have that already, sorry.
Okay, we'll leave it there so. And again, if you think of any questions or anything, just let us know and we'll do our best to answer them. Thanks very much. Bye now.